Hi everybody, this is a recording for those of you who are oral learners and you would like to listen to me explain how you can study for your end of the unit test as well as your vocab and key concepts. So I'm just going to review the Google slide that we went over in class on Tuesday. To start with, let me just let you know that I've included a new slide. This is just a quick capture of the data sheet that I use. So if you're trying to figure out how I grade these, your multiple choice, the number right you get goes right here. And then for those short answer questions, I have a 1, 2, and then a 3 to indicate PB1, PB2, PB3, or Chapter 1, Chapter 2, Chapter 3. As you are writing the answers to each question, make sure that you are including as much information from Chapter 1 in the form of a key concept, Chapter 2 and Chapter 3. And as I read through these, then I'll cross them out. And if you've got like 2 examples, for example, Chapter 2 dealt with convergent and divergent plate boundaries. If you name it, you'll get a half a point. If you name it and explain it like step by step, then you'll get the full point for that Chapter 2 PB. And then your total points go here. I divide your points by the number possible, and that's how I get your score. All right, just a reminder that I want you to please make sure that you are answering each question using the vocabulary words, and make sure that you're using the key concepts to answer those short answer questions. Make sure that you are using precise language. It's very important in science. You are student geologists after all. You're not 7th grade students, and it's very important that you are able to show that you're able to use these terms correctly. And then those are all the words. You guys have your flashcards, so you should have every single word that you need to use. You may not use every word, but it will help you articulate what you want to say if you use the correct terminology. Just a reminder, key concept number 1 is Earth's outer layer is made of hard solid rock. It is divided into sections called plates. That's number 2. And those plates move. That's key concept number 4. We looked at examples of questions that were asked on Chapter 1 or having to do with the Chapter 1 key concepts. Before that, though, it's important that you understand what are some things that we did in class and how can you review those so that you make those connections to those key concepts. So I'm going to show a picture, and I want you to think to yourself, what was it that we were trying to show when we did that activity? I'm going to pause in the video, and then I want you to give you time to think, and then I'll go ahead and say what we were doing just to make sure you and I are on the same page. So what were we doing when I had you guys color this all in the entirety? So we were demonstrating that key concept number 1, Earth's outer layer is made of hard solid rock. How about this one? We were demonstrating that underneath everything that's on Earth's surface, whether it's soil, water, sand, ice, underneath everything on the surface, Earth's outer layer is made of hard solid rock. How about this one? That's the animated video, and if you remember, they removed everything off the Earth's surface, specifically the ocean water, and we could see underneath the ocean, underneath the water, Earth's outer layer is made of hard solid rock. And how about this one? Okay, so what we were doing in the sim is understanding that Earth's outer layer is divided into plates, and that where the plates touch, that's called a plate boundary. So the lime green is talking about plate boundaries. And when we were actually in the sim, we were demonstrating how the plates on Earth move constantly. Okay, in class we went over this question. I'm not going to take the time to do that right now. You guys can go back and pause the video if you want to and reread this, but I'm not going to go over the question. Now let me go to Chapter 2. So Chapter 2, we were talking about the 2 specific types of plate boundaries that we studied, The first one is a divergent plate boundary. And so key concept number 6 says, at divergent plate boundaries, soft, solid rock from underneath the plates rises and hardens, adding solid rock to the edges of both plates. And then key concept 7 says, at convergent plate boundaries, plates move towards each other. One plate moves underneath the other and sinks into the mantle. So each one of these key concepts describes, first of all, it names the plate boundary. And then secondly, it describes what happens at those plate boundaries. And it is very important that you know both the name and what happens step by step. What are the interactions between the plate and the mantle? There were 3 things that we did in class that you could go back and review if you wanted to. So this first one, I'm going to ask you, what did we learn when we read and annotated Listening to Earth? So we learned a lot of things, but specifically we reread paragraphs number 4 and 5, and I had you add more annotations. And specifically, we were looking at convergent and divergent plate boundaries. What happens step by step? What landforms were formed? We learned whether there were volcanoes or earthquakes, volcanic activity at that location. And we learned how the plates and the mantles interacted. So if you want a very quick, if you're a read writer, or if it would help you to look at those annotations again, go back and look at paragraphs number 4 and number 5. You used paragraph number 4 and number 5 to complete this plate boundary comparison chart. You never did turn this into me. I did not take this as a grade. I just wanted you to use this to compare and contrast. And I reminded you all multiple times to make sure that you have step-by-step sequential explanations about how these plates were formed. So if you look at your comparison chart and all you have is just maybe an arrow showing different directions, that's not enough. Go back to your article, write yourself down some notes. What happens step by step? And how do the plates and the mantle interact? What happens to the plates and the mantle at these different divergent boundaries? I know that you all have the correct answer for these last 6, because we went over them in class. If you were absent that day, you may want to ask a friend to double check, or you could go back and look at the videos in that day that you were gone. So this is a great study chart for you, fabulous study chart. And this one, the model, I know every single one of you has this done, and that it's done correctly, because this was the one that you brought back to my desk, and I asked you to verbally defend your answer about what that plate boundary was in between the South American plate and the African plate. And so look at these cross sections. Make sure that you understand what's happening. We labeled what landforms were there. We labeled what directions these plates were moving in. We talked about what was happening. We made a plus sign and a minus sign where rock was being added and where rock was being taken away. So make sure that you really spend some time talking about that to yourself or explaining it to somebody else. Okay, and then we went over several questions here. Again, I'm going to skip those because you can go back and review those, just using the slide. I want to talk to you again about the whole slab, pull, ridge, push. And you are more than welcome to go onto YouTube. And if you just type in slab, pull, ridge, push videos, you'll have a ton come up that explain what's going on. The problem is, you guys, this information is high school information, college information. And so it's really hard to find something that's a really simple explanation. But just remember, we talked just like, you don't want to be in your attic on a summer day in August because it's so hot. And you don't want to be down in a basement, maybe that's not heated in the winter because it's so cold. Hot rises, cool sinks. And so that creates this idea of a convection current. And convection current occurs in the mantle, in this melted rock. It occurs in air. It occurs in the ocean, in waters. And it is a circulation of material that as it warms, it's going to rise, and then it cools. Remember, we talked about the different temperatures here. And so when this melted rock, when this soft solid rock is close to the outer core, it's about 3,700 degrees Celsius. It's very hot, and so it's going to start to rise. And the closer that it gets to the crust, it's going to start cooling off, and it will start to sink. And so we've got this convection current in the mantle. Now, the plate doesn't sink because it gets cooler. The plate actually sinks because of gravity. So let me talk about this. Right here, where we've got this plate boundary, it's a divergent plate boundary. You know that this hot mantle material is going to come up and it's going to cool off right here, and it's going to form hard solid rock. Okay? This is going to give a constant push. It's a force that is pushing the two plates side by side, or not side by side, but away from each other. And remember, this is happening so slowly. We cannot see it happening. And it takes millions of years in order for the plates to move a significant distance. But it is a constant push here, and that's why it's called a ridge push. Remember, this is the mid-ocean ridge. So this is a ridge push, and it's pushing the plate this way. So then what happens is, as the plate is cooling, it actually becomes more dense. Density, remember, is where we have more matter in an area or in the volume than something else that's the same volume. In class, I gave the example, if I had a 1-inch cube of wood, like let's say pine, and I had a 1-inch cube of steel, which one is more dense? Steel is more dense. There's more particles, there's more atoms in steel in a 1-inch square cubed of steel than there is of pine wood. And so if we drop both of those into water, the steel would sink, the pine would not. So as this rock becomes older and more dense, it actually starts to sink. And what happens is this plate, gravity will pull it down. If you've ever seen an example, like if you've taken 10 paper clips and you link them together, and so they're in this big long string, and then you push 2 of them off the table, gravity is going to take a hold of that and pull the rest of them off the table, right? It's all going to go just flying off. And so the same thing happens. When the slab is down here, it's so close to the center of the earth that the gravitational pull is very great, and it pulls it down. So at the same time that the ridge is pushing, the gravity is pulling this slab. So then this breaks up, heats up, starts to rise and cool, and rise and cool, etc., etc. So the convection continues to circulate, and this new rock continues to be added and then drop down at a convergent plate boundary. Nothing that you need to know on the test. It just is helpful, I think, that you understand Earth's cycle as it completely includes both divergent and convergent plate boundaries. Okay? All right, so then moving on to chapter 3. The key concepts that we have there is key concept 8, Earth's plates move at a rate too slow to be experienced by humans. And key concept 9 is it takes a long time for Earth's plates to travel a great distance. I feel like you guys have a really good grasp of this already. You know it's going to take a long time. You see that. A couple things that we've already done in class is when we've been in the sim, you can see that the measuring tool, the time tool, is in millions of years. It's not in seconds or minutes or days or months. It's in million years. So you know that it's going to take a long time. And then also, you guys have been given your key concepts ahead of time. So you know that you've been studying Earth's plates move at a rate too slow to be experienced by humans, and that it takes a really long time for them to travel a great distance. So I'm going to skip those 2 short answer questions, not go over them, except please remember, prepare yourself so that you can use key concepts from all 3 chapters in your response for both of those key concepts, or both of those short answer questions. You need all 3, okay? Okay, you guys, that's all that I've got today. Good luck. Study hard. If you have any questions, please don't hesitate to ask.